We left off right here. We had used the table in order to answer the same questions, types of questions that we'd answered from algebraic equations. So we answered those kind of equations with algebra, and then we did it with a table. All right, now they're asking us a completely different question. We're supposed to find the intercepts of f of x equals 2x minus 7 by hand. Okay, well, there's going to be two intercepts. There's going to be an x-intercept and a y-intercept. Let me make a table right here just to make our lives a whole lot simpler. All right, so we're going to need an x-intercept, we're going to need a y-intercept. Now, how are we going to do this? Well, very carefully. All right, so what you want to do, when you have an x-intercept, remember that an x-intercept means that your y value is 0, right? And a y-intercept means your x value is 0. So for example, it's going to go like this, right? So you're going to have 0 something, and then you're going to have something 0. Those are intercepts. Intercepts are when the other variable is equal to 0. So you can find either one of these. I think the y-intercept is actually the easier one, so let's start with that. So the y-intercept, remember we had f of x equals 2x minus 7. Okay. The y-intercept has x equal to 0. So what I'm going to do is I'm going to put x is 0. So f of 0 is equal to 2 times 0 minus 7, which is negative 7, because 2 times 0 is gone, right? Anything times 0 is 0. All right, so there's our intercept, 0, comma, negative 7. It's a point, so you have to give it coordinates. Don't just say negative 7. Negative 7 alone won't cut it. It's 0, comma, negative 7. Now, if you're wise, you could have noticed that just from the start, because this was mx plus b form, right? So b has to be the y-intercept. So there you go. So negative 7, 0, negative 7. Now the y-intercept is a little bit trickier. So you want y is equal to 0 for the x-intercept. So instead of putting 0 in for x, what I'm going to do is set the whole thing equal to 0. So where there was a y, which was, hold on, this whole big f of thing, right? That is your y. It's just a fancier way to write it. So this thing goes away and becomes 0, right? So you put 0 in instead, right there, okay? So f of x turns into 0, and then you solve it for x. So you're going to add 7. So you're going to say 7 equals 2x, divide by 2, 7 over 2, which is 3.5, is equal to x. So your x-intercept is either 7 over 2, comma 0, or you could also say 3.5, comma 0. That's also perfectly valid. There we go. So I suppose the upshot of it is to kind of remind yourself at all times that when they write this, what they're saying with this big notation over here is y, right? Y is equal to f of x, which is equal to 2x minus 7. F of x, that's how you say that. Of, O-F, right? F of x. Okay, so when they write that, they're really just writing y, right? They don't have to come out and say it, but that's what it means, right? All right, we're done with that. Let's move on to modeling, shall we? Okay, modeling means story problems. More of them for you. I knew you'd be excited. So in section 2.1 and 2.2, we already found this equation. It was the rate at which airlines bump passengers. It was right here. It was the last problem we did in 2.1 and 2.2. Okay, we already found this equation, 0.634 t plus 6.379. Fine. So we're supposed to rewrite the equation, but with a function name of f. Okay, so instead of writing r equals 0.63 t plus 6.38, we are going to write f of t equals 0.63, oopsie, instead of writing your y, which was r in this case, right? Instead of writing your dependent variable, you're going to write f of independent variable. That's function notation. Let me say it again, right here. Instead of writing the dependent, which in your case was r, right? You're going to write f of your independent variable. Let me put it over here. Like in this case, you wrote f parentheses t, right? T. You didn't write the letter r, you wrote f parentheses t. Instead of writing the letter y, you write f parentheses x. That's what you're going to write instead. So for us, we didn't write r, we wrote f of t. That's what they were looking for. That's our answer right there. Done. Now, what is the slope? Well, just because I wrote it with f of t doesn't really change what this was. This is still y equals mx plus b, right? Y is your f of t equals m, 0.63, t plus b. So your slope is 0.63, right? Now, what does it mean? Here's where the fun begins. You have to be able to interpret what that slope means. Okay, at this point it helps us to remind ourselves of a few things about slope. Slope is vertical change over horizontal change. So it's rise over run. It's y2 minus y1, y1 over x2 minus x1, which means it's vertical change over horizontal change. Okay. Or let me put this, change in y over change in x, right? Okay, now where am I getting at with this? Well, I have a reason. Let's just put it that way. All right. So I just kind of want to highlight this somehow. Now in our particular case, this was equal to, and this is where it really pays off to pay attention to your variables. Our y variables, our rise variables, vertical variables, was rate, right? And that was in, better give it units, it was in thousands of passengers, I think, per 100,000, good grief, passengers. Right? Always want to give yourself your unit so you can keep track of what's going on. Okay? And this was time in years. Okay? Again, give it its unit. It was, so for our example, it's the rate over time. That's our slope. Okay, now how is that helpful to me? Well, it actually is, because you're going to use this to interpret. You know how back here you had to kind of think about both points, both the x and the y? Actually, you did it right back here, right? You have to say, oh, I have to interpret the 30 and the 0. Got to do both. Well, you're going to do the same thing here with the slope. You're going to use both these numbers. So when I have negative 0.63, that's really negative 0.63 over 1, right? Any numbers over 1. I'm going to use that. So I'm going to say every 1 year, or every year, the rate at which airlines bump passengers decreases. Decreases. Now, how come I know it decreases? Well, because it's negative. Negative would mean decreasing, right? So it decreases by how much? By 0.63 per 100,000 passengers. It's not like they can bump 0.63 of a person, right? It's 0.63 for 100,000. So if you have 200,000 people, it'd be 0.63 times 2. Or if you have I don't know, 1 million people, it's 0.63 times 10, or 100, sorry, 100, and so on. Okay? So you multiply by whatever is missing. So it's 0.63 per 100,000. Cool? Both numbers. I use the 1 right here. And honestly, we don't usually use the number 1. We just kind of say every year. But that implies every 1 year, every single year, right? Sometimes they write the word single. Every 1 year, every year, right? The rate at which airlines bump passengers is going down. You could also say goes down. Goes down by, decreases, is going down by, etc. You've got to make a complete sentence and you have to explain both numbers. All right, now let's find f of 14 and what does it mean? Okay, well remember we already found our function to be f of t equals 0.63 t plus 6.38. So if I want f of 14, where there was a t, see how t got displaced? T turned into 14 right there. So this t has to turn into 14. All right, so when you do that with your calculator, let's see, quit to get out of here into the main screen. If you're ever on a screen you're stuck and you don't know what to do, second quit. That can get you to the regular one. So 0.63 times 14 plus 6.38. Enter. There you go, 15.2. Now, what does it mean? Well, be careful. You have two numbers that you have to interpret. Okay? You have the 15.2, but you also have the number that you put in to start with. You have to interpret both of them. So in what year? Right? Here, let me make a note to yourself. To you, not to me. This is T, comma R, wasn't it? So this was 14, comma 15.2. I gave you the 14. You found the 15.2 for yourself. It totally pays to some point somewhere write down what your variables are in an ordered pair. So we're saying, hey, in the year 14, which our starter year for that problem was since 2000. See, that's the starter year. So in 2014, there will be about 15.2, or wait, how about this? The rate at which airlines will bump passengers is expected to be about 15.2 per 100,000 passengers. Okay, so it's going down and it's expected to be about 15.2 in 2014. Right? Now again, the 2014 came because, right, note the starter year was equal to 2000, right? So 14 is 2014, right? And again, you always have to interpret your both points and you've got to give it its unit. Be about, right? This unit was per 100,000 for the bumping rate and then the year. Done with that one. Now the next problem is not the same thing. It's not f of 14, it's 14 equals. They want you to find t when, here read it, t when f of t equals 14. So you're going to have to say 14 equals this, like that. Alright, so that means you're going to have, let's see, subtract 6.38 from both sides. You're going to get 7.62 equals 0.63t. Hold on. Right? Subtract 6.38, then divide by 0.63. You're going to get t is about 12.095. Okay? Not the same problem at all. This one's set equal to 14. This one's 14's in the parentheses. When 14's in the parentheses, you put it in for t. When it's set equal to 14, you set it equal to 14 and solve. Now I'm going to have to stop there and pick up on how to interpret this next time.